Hello, everybody. This is Sunday. It's October 9th, and we are moving into Module 7 of our online astronomy course. Today is October 9th. Sunday is the full moon, and the full moon in October is called the Hunter's Moon. And that's because this is the time of the year when hunters of Native American tribes would have to store up meat for the winter, and so they would go out hunting by moonlight. That's where it's thought the name Hunter's Moon comes from. But have another piece of astronomy news for you. And if you remember last module, you were learning about the moon. And I just saw yesterday, as a matter of fact, this great new video of the moon's formation. And this is the highest resolution video. The video that, the calculation can follow very small particles, and it can follow them over a bunch of short time periods. So it's a lot more accurate than what we've seen in the past. And it shows the moon forming in about a day. This is very similar to what's in your book, but the simulation is a lot better. And I just thought I would share that with you. So here it is. And this is from NASA. I'll just go down here, and here's the simulation. So let's just start this. And you're seeing the collision first, and then we'll go through it and see what's really going on. This is a new super computer animation, simulation, calculation that shows what happened when this Mars-sized object came in, hit Earth, and ejected enough material to form the moon. So let's go through it here. And here comes this Mars-sized object, comes in, hits Earth a glancing blow, and just shears off a bunch of material. Now, none of this is an animation coming from people's imaginations. This all comes from careful calculations. You can see there's a larger object and a smaller object. The larger one falls back into Earth, and the smaller object goes into orbit and becomes our moon. Now, as I said, this is the result of computer calculations. And what is nice is that this seems to be a robust outcome. What I mean by that is that you don't have to really fine-tune a bunch of parameters to have this happen. That it seems to happen in a lot of cases, and that makes it a lot more probable that this is indeed how our moon was formed. Pretty cool. But in this module, Module 7, we're going to be moving outward from the sun and looking at the first 4 planets. Those are the terrestrial planets, Earth-like. And what does Earth-like mean? It means that they are small, that they are rocky, and that they are more dense. They're not gaseous, they're made of rocky material. And those 4 are Mercury, Venus, Earth, that we covered in an earlier module, and Mars. And so these 4 terrestrial planets are distinguished from the outer Jovian planets, Jupiter, Saturn, Uranus, Neptune, because those are all large and gaseous and not very dense. So the solar system is really divided very cleanly into 2 sorts of planets. And we're looking at the terrestrial planets, the Earth-like planets, in this module. Now, Mercury is about the size of the moon. It is heavily cratered, just like our moon is. It has no atmosphere, just like our moon doesn't have an atmosphere. So it's quite similar to the moon. Now, Venus, on the other hand, the next one out, it's about 70% as far from the sun as Earth is, so it's a bit closer. And it is about the size of Earth. It's as far as size goes and mass goes, it's a near duplicate of Earth. However, the difference lies in the planet's atmospheres. Venus has a very, very thick carbon dioxide atmosphere. That means there's a super greenhouse effect that is driving up the surface temperature of Venus, so that the surface temperature of Venus is even higher than the surface temperature of Mercury, even though Mercury is much closer to the sun. And so the surface of Venus is a very inhospitable place. There's only been one mission that actually managed to land and take photos. I think there are two missions. They're both Russian missions, and you can see those pictures in your book. But Venus, very hostile. Of course, Earth, we already know about. It fortunately does not have a carbon dioxide atmosphere, but the number of carbon dioxide molecules in the atmosphere is increasing. And that is what's driving up our temperatures and changing our climate. The planet we really know most about, outside of Earth, of course, is Mars. And since 1976, when we first landed the Viking landers on the surface of Mars, I remember that happening. It was very exciting. But since then, we've been exploring Mars. And of course, we haven't had humans on Mars yet, I hope. But all of the spacecraft have been robotic missions, either orbiting the planet, observing it from orbit, or actually landing on the planet. And in the early days, it was really hard to land on Mars. Only about half of the missions succeeded. And we are doing much, much better than that today, fortunately. But Mars is odd. It's about half the size of Earth. It too has a carbon dioxide atmosphere. Its atmosphere is almost all carbon dioxide, but the atmosphere is so thin that there's not very many carbon dioxide molecules to cause a greenhouse effect. And so in fact, Mars, because it's about 50% farther from the sun than Earth is, it's pretty cold there. You know, in the middle of summer at the equator, it might get up to 50 degrees Fahrenheit. You know, that's a nice temperature. But during the winter, it gets down to like minus 67 degrees Fahrenheit or something like that. Very, very cold. And so it's not a very hospitable place either. And also the atmosphere is, as I said, very thin. And so the surface pressure on Mars is very low. But we've sent a number of robotic explorers to the Martian surface to explore. And the latest, which landed in February of last year, is called Perseverance. And if you look over my shoulder here, you'll see Perseverance. It's about the size of a car, and it's driving around the Martian surface, exploring. It also has a little helicopter named Intrepid, and that helicopter can fly ahead and scout out the surface features ahead of the rover, so the rover knows better where to go. And the rover has a robotic arm. And I don't think you can see it in this picture because it's folded up, but the robotic arm, whoa, I'm out of focus, hello. The robotic arm can reach out and drill into the Martian surface and lift out a core sample. And it puts those core samples into tubes about the size of my finger, and it leaves them on the Martian surface, as you see here behind me. A later mission is going to go to Mars and pick up those tubes, those samples, and return them to Earth. Perseverance, just the landing of Perseverance was a great achievement. It landed in very dangerous terrain, and it has been looking around a place called Jezero Crater, which was once a lake filled with water. And you'll see what the Perseverance rover has found in Jezero Crater in a video that's in this module. So you'll be learning all about these fascinating terrestrial planets. And next time, we'll be looking at Jovian planets. So before I go, I want to show you how to find Mars in the sky. And I was just lucky because 2 mornings ago, I got up early and I went outside at about 6 in the morning. And this is 6 in the morning, Monday morning. But the view will be the same any day of the week. So if you go out early before the sun rises, first of all, I looked to the south and I looked up and there was Orion hanging in the sky. My favorite constellation in the sky, Orion. Here's the red giant star, Betelgeuse. Here's the blue-white giant star, Rigel. Over here in the constellation of Ursa Major is the star Sirius. That's the brightest appearing star in the sky. And it's bright mainly because it's so close to us. But if I look upwards above Orion, there's Mars hanging in the sky. And it really was a fantastic sight to see Orion, to see Sirius out there, to see the constellation of Taurus, which is over here a little bit further to the west. And this is the red giant star Aldebaran, which is the eye of that bull that represents the constellation Taurus. In fact, here I can put the constellation figures up for you. And you can see here is Orion the hunter, here is Taurus the bull, and Mars is right between the horns of Taurus. So go out, take a look, and I hope you enjoy learning about the terrestrial planets in this module. And as always, I'll remind you that you can always email me with questions. I can set up a Zoom meeting with you if you like, or you're welcome to drop by my office and have a chat. So have a great week. And until next week, I will look forward to seeing you then. So until then, bye-bye.